Hello, now we're going to talk about some of the structures that are used to alter um, aquatic systems. So, first, levees. Levees are primarily earthen walls that are built along rivers to keep the river from flooding, from spreading into the floodplain. Um, and they are quite commonly used. And here's a photograph of one that you can see here, and it runs along here. Not terribly dramatic thing from the air because it slopes up, but they can be anywhere from 10, 20, even 30 or so feet high. Um, and again, they're used to keep the floodwaters from getting into the floodplain, these areas that they will normally spread into, but because of farming and development, we don't want the water to flood those areas, so we build a levee. So a river, of course, has its normal course, and then there is the floodplain, as you can see. And so what we'll do is build levees to restrict the river to its regular channel and not allow it to spread out into these developed floodplains. In cities and towns, the levees are typically built of concrete walls um, out where space is at a premium, but outside of town, there'll be those earthen mounds that run along the river. Of course, levees can fail, both the earthen kind and the concrete kind, and then the water essentially spreads out into the floodplain. With Hurricane Katrina in New Orleans, it was the concrete type that gave way inside the city that allowed for flooding of those neighborhoods. Um, how do levees promote flooding? Well, when you have a series of levees along a river, um, essentially the water upstream, when you have a period of high water flow, is not allowed to spread in the floodplain. It's restricted to the river. So instead of the floodplain taking on some of that water so that there's less going downstream, slowing the rate at which it's going downstream, more of the water is being funneled downstream faster. And so further downstream, because you have all this water showing up, it can cause flooding there, in particular if the levees fail or the water is so high that it runs over the levees. Okay, so now some of the opposite issue here, the situation in which you have not enough water. So Las Vegas, this large city, many people living out in the desert. Of course, a desert defined as an area with 10 inches or less of rain a year. Um, But you can see in Nevada, this pretty dry state, and most of the people live down here in Las Vegas or up here in Reno. They have some of the highest per person uh, rates of water use in the country. Um, and curiously, some of the states that are quite wet, Minnesota, Wisconsin, uh, and some of these upper Midwestern states, have some of the lowest water use rates in the country. Uh, the number represents projected population growth, and so you can see some of these states that use a fair amount of water are going to grow quite a bit, and so they're going to have to find a way to use less water per person because there is only so much water out there. Indeed, in the US, we use a lot of water. This is in liters, notice, and a liter is 3.5. I'm sorry, there's 3.5 liters to a gallon. Now, these countries out here are quite poor, and so they have a very simple lifestyle. They don't have a lot of stuff. They don't use a lot of water, but there are countries on here, as you can see, the UK, which is just as wealthy as we are, and then people live just as comfortable a lifestyle, but you can see they use a lot less water than we do. So we have a long ways to go in our efficiency in using this particular resource because we use a lot in ways that aren't perhaps necessary, and I'm not really reflecting here on the fact that this girl is running through the sprinkler, the fact that the sprinkler is being used to water a lawn, and of course a lawn is really a non-essential thing. It's just there to look nice, and we use a lot of water keeping them look nice. And of course there are places on the planet where there's not a whole lot of water, and presumably this woman has to walk quite a ways probably to get to the well, so her family is not going to be using much water, strictly for essential purposes. Um, when you take water out of the ground, it can compromise the stability of the ground, and particularly in a place like Florida where the water table is pretty shallow, close to the surface, and this sinkhole is formed, swallowing this house. Um, all right, so out west, the Colorado River. We talked about that a bit. It drains out of western Colorado into Utah and then into Arizona. And so it's primarily fed from snowmelt in the Rocky Mountains that flows west. And that snowfall has been down, so the flow in the Colorado River has been down. The lakes or reservoirs that are along the river are the lake levels have been dropping. Um, Here's a look at the whole schematic. Again, we're at a higher elevation up in Colorado River and the Green River, which is in northern Utah. Lake Powell, which was established in the 50s and 60s behind the Glen Canyon Dam. Lake Mead in the 30s behind the Hoover Dam, and then a couple other smaller reservoirs. Um, this whole system was thought out and established in the first half of the 20th century, which is thought to have been a relatively wet period in that region's history. And so they were assuming there would be that amount of water just for on and on and on, but we've been in a dry spell, an extended dry spell, so it's thought that perhaps that early 20th century period was somewhat anomalous, and so that this system is essentially going to have less water flowing through it. And so the states and the cities and towns that rely on Colorado River water are going to have to make do with less. So here's the Glen Canyon Dam, which impounds Lake Powell, which is upstream of Lake Mead and the Hoover Dam. Large body of water out in the desert. You're going to get a lot of evaporation, a lot of loss of water from that lake in that hot, dry climate. Some little history. John Wesley Powell, Lake Powell is named after him. He was the first leader of a group that surveyed the Colorado River in 1869. You can see explorers had been out there. Of course, Native Americans lived out there for a long time, but they were the first to basically travel down the river and do a geographic assessment of it, if you will. He wrote that, in his opinion, this part of the country was not a good place to settle because it was in the desert and because there was not enough water for this region. Now, of course, he could not envision large dams that were built in the 20th century, but perhaps his thoughts were correct in the sense of we perhaps shouldn't have settled this area to such an extent, because indeed the lakes are down, and that's quite a distance, probably 100 or so feet, that was inundated but now is exposed, and you can see this, they call the bathtub ring effect. This little mound here was an island at one time, but now with the lake level down, it's connected. Shorelines have receded. Marinas have had to move their docks and everything further out as the water has receded and put in new roads. Here you can see this river that feeds into, I believe, Lake Mead, and how it has, because of decreased flow, more of the what was the lake bed is now exposed. Um, when we so rivers have a natural flow, obviously, and so there's a seasonality to it. In the spring and early summer, there's higher flow because of the snow melt or increased rain, and then it drops as you go later in summer and fall and winter. Um, and so the wildlife and the fish that live in the river are used to this seasonality, a time of low flow and times of high flow at particular times of the year. Well, when we start building dams, we start controlling the flow of the river, and there are competing interests for this. you want to generate electricity, and when you need to generate more electricity, you want more flow coming through the system. Um, and curiously enough, when there is less demand for electricity, is when that river is normally flowing a lot. And when the flow is decreasing is when you need more electricity, so they're kind of out of sync. If the river is used for navigation at all, which the Colorado River is really not, but there are many rivers in the mid and eastern parts of this country that are, you want very consistent flow, because if you're a barge operator on the Mississippi or the Cumberland or the Ohio, whatever, you don't really want to deal with periods of low and high flow. You want it to be the same all the time, which for any river really is not natural at all. Um, and then, of course, recreation has its times during the summer in particular when you'd like to have more water in the system. All right, so here's the Glen Canyon Dam, which impounds Lake Powell again. And so when you when you dam up the river and form a lake, again, you disrupt the flow significantly. And in particular, those high flows that you get in the spring and early summer, really they don't happen anymore. And so that can have a negative impact on the wildlife downstream. And so this image is for me to remind you reminds me to tell you that what they have started to do is try to mimic some of those periods of high flow. So this is a springtime release of a large quantity of water. And this is water that is not flowing through the dam. The water that flows through the dam to generate hydroelectricity comes out at the bottom of the dam. But this is coming out through tunnels that go through the rock, the cliff side, if you will. And so they're just releasing extra water, again, to try to mimic this period of rapid flow that you would normally see in the springtime.